Hello guys and welcome to a new video of the MYP Masterclass. Today we're gonna be seeing some maths and we're gonna see inequalities, which is a topic that's gonna start appearing a lot on the next few years until you graduate. So we're gonna see how to represent inequalities both in a graph and in math language and how to solve them. But what are inequalities? And it's actually pretty simple. As the name states, it's a relationship between two expressions that are not equal to each other. So the symbols are pretty easy. Do you remember the crocodile? The one that you talked like in third grade or primary, I don't know. That's the one. So when two quantities are equal, that's why like the one we know, the two lines P equals Q. When they are not equal, it's basically the equal sign but with a line in the middle. So it's pretty easy from there. Now when it's greater than, let's say Q is greater than P, then it's, well, the crocodile, as we said in primary, showing like Q is greater than P. When it's greater than or equal to, we have the same as greater than but with a line on the bottom. Then when it's less than, so Q is less than P, then it's the same but backwards. And less than or equal to, it's pretty much the same, just with a line in the bottom. So now that we have those basic signs covered, we're gonna see some rules of the inequalities. And basically, rule number one, the easiest one, is that when inequalities are linked, we can jump across them. Let's say, here an example, if A is less than B and B is less than C, we can jump B and go straight to A is less than C, so it's easier to solve it. Rule number two, if you exchange the values, the signs also reverse. So let's say we have P is less than Q and we exchange the sides, well, the sign reverse, so it's still going to be, well, Q is greater than P. Now rule number three, an inequality can be greater than or less than, but never both at the same time. And this might be a little bit obvious. So if x is greater than y, it's impossible to have x less than y at the same time on the same equation. Same if we have x is less than y, it's impossible to have an x is greater than y on the same equation. It's just kind of logic. Now rule number four is that when multiplying both sides of the inequality by a negative sign, it reverses the sign. So we're gonna be seeing more of this rule later on. But basically, if we multiply the whole inequality by -1, you see here the P is less than Q becomes that negative Q is greater than negative P. So we reverse the sign. Now rule number 5 is that when taking a reciprocal, it also changes the direction of the inequality. So if we see some examples of if you guys don't know what a reciprocal is when you put the number over 1 over the number. So if P is greater than Q, then 1 over P is going to be less than 1 over Q. See, we changed the signs right there. Rule number 6 is adding or subtracting the same quantity to each side of the inequality does not change the inequality sign. So same as in equations, if we have P and Q and we add R to both sides, the inequality sign stays exactly the same. It does not change. Now rule number 7 is that when dividing or multiplying by a positive quantity on each side of the inequality, it does not change the inequality sign. So same as adding, if we multiply here by R, the sign stays exactly the same, or same if we divide by R. Now, rule number 8 and last rule is that when dividing by a negative quantity on each side of the inequality, it reverses the sign. So again, like when multiplying by a negative number, when we divide by a negative number, it also reverses the sign. So here we can see the sign changes sides. So now, how do we represent this graphically? Let's say we want to see the less than graph. So if x is less than 1, then the graph would be like this. It would be a number line, and you see this is 1, and it goes all the way because x is less than 1, so it can be every real number that it's less than 1. So it's represented with a line right there, and it's very important to use the arrow because that represents it's a negative. It's infinite, I'm sorry. Now we have the greater than. And, well, if x is bigger than 1, then it's exactly the same, but then x can represent every value that it's, well, bigger than 1. So we also use the line and the arrow to represent it's an x can be infinite number, it can be 1 million, 3 billion, and then, yeah. Now, the less than or equal to, and here you have to notice that for the less than, the circle was opened. So now here, the circle, you see it's colored. So when x is less than or equal to 1, here we use the same arrow, but now we fill in the circle. And it's the same with greater than or equal to, that, well, you cannot see it here, but x can be equal to 1 or any other value that's bigger than 1. So we put a filled circle right here and then an arrow. So here we have it more clearly. So we use an empty circle to show that the limit value is not the solution to the given inequality. So in this case, x cannot be equal to 1. Now, in the second situation, the filled circle is used to show that the limit value is the solution, can be the solution of the given inequality. So we filled in the color, and now we see that x can be equal to 1, and then it also can be any other value that's less than 1. So there's also another way to represent this, and it's in a math language. So in the case of the upper number line, that, well, the circle is opened, so we represent it like this. And you guys see that, well, it goes to negative infinite because the line is infinite, and it stops at 1, but we use a parenthesis to show that this is opened and that x cannot be 1. Now, in the other case, well, it also goes to infinite, negative infinite, but then it stops at 1, and we know that x can be equal to 1, so we use a bracket instead. So it's easy to remember like this: parenthesis when it's opened, bracket when it's closed. Okay, so now we have here some examples that you guys can do and see if you get it right. So, okay, we're gonna, well, if you already paused it, we can go through some of these together. So here we see that x is less than or equal to 1, so x will go all the way here. Now, in the second one, we see that x is bigger than 4, so where would the arrow go? Here. And the circle would be opened because x cannot be equal to 4. Now here we have two different numbers. So in this case, x does not go to infinite, it stops at two different numbers. So here we know that x is bigger than -6, so the first circle would be right there, and it's opened because it's just bigger than, and x is less than 3, so the second circle would be right here, and it also would be opened. And then we have the whole line. So x can be any value in between negative 6 and 3. Now in the other one, which is this one, well, you can try it yourself. Now x is bigger than or equal to negative 5, so the circle is filled in, and x is less than negative 1, so there goes the second circle, and same with the last one. The last one is kind of like a trick question because you really have to pay attention to the signs, but it would look something like this. And now if we do it in the other notation, you can see here that, well, it is closed, the circle is closed, so this is closed and then this is opened, as you see there. Well, in here the circle is opened, so it's opened. In here both circles are opened, so we can live both with a parenthesis. Here it's a little bit different because, as we can see, negative 5 is closed and negative 1 is opened, so we leave negative 5 with a bracket and negative 1 with a parenthesis. And same happens here. Negative 5, we can see that it's closed and 7 is opened, so negative 5 goes with a bracket and 7 goes with a parenthesis. Now, solving inequalities is very easy. It's just like solving an equation. Instead, you don't have an equal sign, you have an inequality sign. So here we have a really basic equation, and well, here we have to isolate x. And how do we isolate x? Well, here we just have to subtract 2, which would give that x is bigger than 10. So that's the basic fundamentals of how to solve an inequality. It's just like solving an equation. You have to isolate x. You also have to be careful with the changes of direction though, because as you remember with our rules, if we the safe things to do when the signs does not change the direction, you can add or subtract a number from both sides, just as we did here. You can multiply or divide both sides by a positive number. Remember, if you multiply by a positive number, it won't change sides. Or you can simplify a side. Now, the direction changes when multiplying or dividing both sides by a negative number. That's a really important rule we have to remember. And when swapping left and right hand sides. So, here we have two inequalities at once, which is just as we saw earlier that x will not be infinite, it will stop two different numbers. So what do we have to do here? To isolate x, first we have to subtract 6. So here we need to take into account that we have 3 different parts of the inequality. So if we subtract 6 from the center, we have to subtract 6 on the left and then also on the right. So we always have to do the same on both sides, on all 3 sides actually. So here it's a minus 6, here it's a minus 6. It would give negative 8. It's less than negative 2x, which is less than negative 2. And now we have to divide by negative 2. So we divide by negative 2 on both sides, but remember that we're dividing by a negative number, so in this case our inequality changes the direction, and this inequality, the solution would be that x is bigger than 1 and less than 4. So, well, yeah, you have to really pay attention to the changes in direction. Here are some inequalities that you guys can practice, so you can like pause the video and then I'll show you the answers. Okay, so these are the answers, and then yeah, that's the video for today. Thanks guys, I hope this helped clear the understanding on inequalities, going through all the bases. And yeah, remember, we'll all keep uploading every Thursday. And yeah, I'll see any suggestions or questions you guys have in the comments. If you guys want me to do a video on any other topic, I can do it as well. And yes, I hope it was clear for you guys. And see you in another video.